Okay, next is called your limiter. Now, under limiter, there are two types of limiter. Okay, first one is called your amplitude limiter. The other one is called your rate. Now, amplitude means how high. Okay, if you want to equate is how much force you want to apply. Okay, rate is how fast you want it to apply. Okay, so why we need this limiter? Okay, example, if we are flying, let's say at 10,000 feet, okay, and suddenly there's an air pocket, we drop by 1,000 feet, okay, and the autopilot will detect there's a 1,000 error, okay, so he's supposed to compensate, or he's supposed to move your elevator to climb your aircraft back, correct? Okay, now, when he detects this 1,000, okay, he will want to move your elevator at the try to compensate for the 1,000 feet. Okay, so the movement of that elevator could be too fast because the error 1,000 could be too large. Okay, we don't want it to let's say from point A. From point A is where he detected the error, and then point B he already reached 10,000. Okay, cannot be so fast. Okay, there must be a time for it climb. Okay, so he can compensate so fast, but the thing is now aircraft is still moving. Okay, so there is still air applying on your elevator, everything. Now your elevator need to move, and when it moves, it's actually cutting against the air, so there is some resistance. Okay, so if the compensation is too strong, if the amplitude is too high, okay, that means the force applied on the elevator is very strong. The elevator will try to deflect. Okay, will try to deflect. Okay, when it deflect and let's say it cannot take that air load, the elevator will get blow off. Okay, that is talking about amplitude, meaning amplitude is talking about the force. The force is acting on the surface. Okay, now and rate is talking about how fast. Okay, you don't want it to instantly boom. Okay, if you want it instantaneous like that, okay, same thing, it may not be able to overcome the air load, and it may get ripped off. So we want it to slowly go down, okay, then slowly climb up, okay, because we have plenty of time, okay, unless it's an emergency, because usually on emergency, okay, autopilot will not help you to take care, okay, pilot will be the one taking over control, okay. So this type of cases where pilot is piloting the plane, then they can do the override, meaning they can really max it, okay, move it very fast and then deflect a lot. Okay, you want the compensation to be done as fast as possible, no choice, because it's in emergency. Okay, but under autopilot, you don't need to have so immediate and drastic changes. Okay, so this limiter is actually to limit those corrections, okay, so that it will not exceed the structural stress on the surfaces itself. Okay, that's why we need all this type of limiter. Clear? Clear lah? Clear? So please take note. So this limiter is operating when your, let's say, is in autopilot mode, all these things. So where you can do your compensation at a fixed timing, or you are not in an emergency, okay? Clear? Okay, I think this is my last slide. Okay, next, okay, not last slide, okay. One more slide. Okay, one more slide. Okay, modulator. Now, modulator is, well, this is a bit tricky. Now, what modulator do is we are trying to use a signal, we call it a carrier, okay, to help us transmit our original signal or data to a far away distance. Okay, one of the example I can give you is like, now you all can hear your FM radio, right? The DJ talking, right? They are talking in the station, but you can hear it. Okay, what I do is that when they talk, their voice data, the signal will go in and then combine with one carrier signal. Okay, this is called carrier signal. Now, when these two signals combine together, it's called a modulated signal. Okay, the reason why we want to do that is that now, if you don't have this modulated signal, your original signal cannot travel and transmit far. Okay, it's just like when you shout, how far can your sound be heard? After a while, you cannot hear already. Correct? So there's a distance limitations. Okay, so we want to transmit, let's say, from here to another place. Okay, we need to use a signal that help us to bring this signal to another place. Okay, so that is called a modulated signal. So what we do is now, that means we will have one original signal, I call it data. Okay, then plus a carrier. Okay, then these two combine together. Okay, then it becomes what we call a modulated signal. Okay, so if you look at my screen, okay, this one, the first one is your original signal. Okay, the red and the blue one is your modulated signal. Now, modulation, there are a few methods. Yeah, amplitude modulations or frequency modulation. Now, the one that is commonly used is frequency, FM. Okay, how it works is that if you look at these animations, when your signal go up, okay, go to a positive peak, what happened to the frequency of that carrier, a modulated signal? It increase or it decrease? How you know it increase or it decrease? Now, if it get more compressed, that means the frequency is high. Okay, when it expand out, that means the frequency is low. Okay, so if you look at this signal, when your original signal is a peak, okay, your frequency, modulated frequency is high. Okay, then when your signal is negative peak, it will give you a low frequency. Okay, from this signal, you can actually know that your data is what type of data. Okay, so with this, we can actually transmit far. Okay, so now if you look at amplitude modulations, okay, your shape of your modulated signal actually follow your original data amplitude. Okay, the frequency is same, but it's the shape. Yeah. Okay, now one thing no good about amplitude modulation is that because your original data amplitude may go very high. Okay, and when you transmit, the modulated signal may not be able to transmit such a high amplitude and get cut off. Okay, that's why if you can, I don't know whether you can change back to AM, you listen to the quality of sound between AM and FM. Okay, you'll find that the AM sound is a bit flat and a bit like down like that. Okay, but you look at, if you listen to FM one, it's more stereo. Okay, and you can hear the loud and soft. Okay, so that is modulations. Clear? Clear? Okay, so confirm last slide. Okay, when we transmit this data, we want to receive, right? So this demodulator is something like your filter lah. Okay, once I transmit, I need to filter out my filter back my original data. So on the receiving end, which is your radio, okay, actually act as a filter. It filter out the carrier frequency, okay, and then left behind is your original data. Okay, for example, FM 95. Okay, that means when you tune to 95, you are actually filtering out 95. Okay, whatever is left behind is the, let's say, the DJ voice, the music that they play. Okay, that's how it get transmitted to your radio. Okay, get broadcast into your radio. Clear? Clear now? Clear? Easy, easy. Now, demonitor, there's also one more function. Okay, modulator and demonitor, there's also one more function. Okay, in a synchro system, we will study in chapter 2. Now, synchro is just a sensor that pick up errors. Okay, it actually, in a modulator, is actually help us to convert. Okay, convert signal, AC signal, to what we call a polarity signal, DC signal. It is not rectifying, not rectifying. Now, for example, if I have signal A and signal B, Okay, if I have a signal, okay, if I have a signal going in, okay, this signal is a sine wave like that. Okay, and the output here is a motor. Then this motor is a DC motor. Okay, so I need to use DC to drive the motor. Now, I know that you all know that motor can turn clockwise and anti-clockwise because it depends on the polarity that's applied. Okay, so for example, if the signal like that going in, it should drive my motor clockwise. Okay, but if the signal change to like that, can you see that the phase is different? Okay, it should drive my motor this way. Okay, so what this do is that when this signal go through a modulator, I will cover this in chapter 6. Okay, it actually convert the signal, this AC signal, to a DC or to a positive or negative signal. Okay, so that it can actually drive your motor clockwise or anti-clockwise. Okay, so modulator in the synchro systems is also used to convert AC signal or compare okay, AC signal that is in phase turn clockwise, out of phase turn anti-clockwise. Meaning in phase it will give me a positive value, out of phase it give me a negative value. Okay, so that my motor, because my motor is a DC, it only recognize DC. Okay, so if you don't have polarity, come to me, I don't know which direction to turn. Okay, so the modulator actually help us to convert this into a positive or negative signal. Clear? Clear? Okay, so this is my last slide. Any questions?